Let us wait a few more minutes so that others can also join. Hello all, welcome back to today's interaction session. In the last class, some of you have asked me about the weightage of assignments. I think Rilvana has asked me, right? Regarding that,
Yes, ma'am.
regarding that, about 10 out of 12 assignments, which is having the highest score, will be taken for final evaluation. So that is the that is how assignments are taken. So I hope it's clear for you now.
Yes, ma'am. Thank you, ma'am.
Okay, thank you. And another thing is that if you have any other queries, you can ask here. So this forum, this interaction session is for your doubt clearance and for raising your concerns. And we shall be solving a few questions which will be helpful for you to solve assignment questions as well as for other competitive exams. So I guess we can start the session now. So let me share my screen. Any queries? Anyone have? Okay, good. If not, let us start. hope my screen is visible to you. So, welcome back. In today's interaction session, we will be dealing with the what you have learned in week 5 NPTEL lecture videos. We will be solving a couple of questions, and that will be helpful to solve assignment questions, I think, which is due tomorrow. So, for all the newcomers, a brief introduction about me. I am Sethulekshmi, Prime Minister's Research Fellow and a third year PhD student in Environmental Science and Engineering Department, IIT Bombay. So, I'll be hosting this session for you to solve and to clear your doubts regarding what you have learned in the week 5 of your NPTEL class videos. So, I'll give you a brief introduction about what all topics were covered in week 5. So, regarding first of all, the lecture started with wastewater. What are the objectives of wastewater treatment, and then the class was focused on what are the current discharge standards for different pollutants based on the CPCB manual and other standard textbooks which we follow, and then we were moving towards the what are the current municipal wastewater treatment stages. Mainly we have the preliminary treatment, primary treatment, secondary treatment, tertiary treatment. So these four were discussed and in general, and then you would have learned about what are the unit operations and unit processes, and then after that in particularly in the week 5 we have learned about primary sedimentation tank, like about you would have learned about type 1 settling, type 2 settling, type 3 settling, and type 4 settling, along with some problems related to the screens, then problems related to grid chamber design, and also primary sedimentation tank design. So these were the topics covered in the week 5. So now let us move on to the problems. So here we have the first question. I need a participation from your side. So please kindly note that this is an interaction session. So you are free to mark your answers. So like don't be shy to share your views or answers or concerns. So let us see the first question. First question is factors affecting sedimentation process in a sedimentation tank are A. Particle properties, B. Fluid properties, C. Detention period, D. All the above. So any answer, anyone? Anyone?
It is D.
D. All the above. Okay, let us see the answer. Yes, it's correct. All the above. So you would have learned about sedimentation process in a sedimentation tank, particularly this physical settling process, which is predominant in primary sedimentation tank. So you would have learned about the type 1 settling, type 2 settling, type 3 settling, and type 4 settling. So based on the what all factors that affect this physical process of sedimentation, we can say that the particle properties play an important role in particle settling. Particle properties like density, size, shape, etc. So these factors, they play crucial role in like how much time they will settle or whether it will settle or not. So the next thing is fluid properties. Obviously the the medium in which the particle is settling, for example the even this the density of water, we say like we normally take as 1 gram per cc. It won't be the same for the sewage water which we are talking about. Density would be different, so the settling characteristics of of the particles would also be different. So fluid properties play a crucial role. The next thing is detention period. Detention period means like it is like sometimes for settling smaller particles more time is needed than settling larger particles, means the particles which are denser. So detention period also play a role in the sedimentation process or the efficiency of sedimentation process. Hence the answer is D, all the above. So I hope it's clear for you. If there is any doubt, you can ask. Else, we will move to next question. Okay. Since there is no concern from your side, let us move on to next question. So next is a match the following type of question, in which you have to match pollutants on left side with the corresponding treatment unit on the right side. So on the right left side you have gravel and sand. B is scum and foam producing matter. C floating and suspended matter. On the right side you have bar racks, grid chamber and fine screens. So here some options are given regarding the match. So I request all of you to try this question and say your answer. Any answer, anyone? Anyone? Okay, let us see the answer then. So the answer is D, A against 2, that is gravel and sand. It is matched against uh, grid chamber. Then B against 3, that is floating and suspended matter against bar racks. Then sorry, I'm sorry. So you have B against 3, that is scum and foam producing matter against fine screens, and floating and suspended matter against bar racks. So this is how it is done. So coming to each process one by one. So let us see, first you would have learned about the screening process. So in the screening process you would have learned that all the bigger impurities, like floating objects which are very huge in size, they will get like floating and suspended matter. The initial process of wastewater treatment is like removing them from the wastewater which is going into the subsequent stage of treatment. So we use various screening methods, and bar racks is one among them. Hence floating and suspended matter is matched against bar rack. The next process was like sometimes some of the particles would be large enough, like in size which is large enough, and they will be floating like scum and foam, scum, etc. So they will be large enough and lighter for other treatment unit like grid chamber, and they will be floating in nature. Hence we use fine screens. In the screening method you would have learned about different type of screens like fine screens, micro screens, etc. Based on the size of the floating material, we decide the size of the pore size, and based on that the nomenclature is given for the screens. So the scum and foam producing matter is matched against fine screens. Next you have in wastewater stream, once the floating and large objects are removed, you have all the denser objects like sand, grit, and all, uh, gravel. So all those things are to be removed. So which is typically having the specific gravity around 2.65, that range. So for that we go for grid chamber. So hence A is matched against 2. So I hope hence our answer is D. So I hope it's clear for you. So if there is any doubt you can ask. Shall we proceed to next question? Shall we proceed to next question?
Yes,
The-
please.
okay, thank you. So let us see the next question. So the next question is, which of the following statements are true? First option, screenings are often disposed of in the sanitary landfills. Option B, screens and grid chamber are examples of unit operations. Option C, communicating device shreds coarse solid materials and return them to wastewater flow. D, all the above. So answers, like you are free to mark your answers. Please say out your answers.
Ma'am, we are all answering in the chat box.
Okay, since like I'm sharing the screen, I'm really
Okay,
sorry that I'm not able to see the chat box. If I'm going to see the chat box,
no
then
issues.
yeah. So
We'll,
that's
we'll,
why,
we'll,
yeah.
we'll give our answers here right now.
Okay.
Thank you.
So if you are telling directly the answer, then that would be fine because then I will be able to know the answers.
Most of us have answered D.
Okay, thank you. So D is the popular opinion. So let us see the answer. Yes, that's correct. Very good. So D is correct. So let's see one by one. So these statements are taken from the lecture notes or the PPT which is taught in the class. So these are all like statements which are taught in the class, and I have taken from like those lecture notes about each processes. So first let's see screenings. Screenings, what we meant here is that what all things are removed by the screening process or the initial screening process which we do, what all things are removed, all the floating objects and everything which are removed in the screening process, those are known as screenings. So options A says that they are often disposed of in sanitary landfills, which is true. All those floating objects which are removed in the screens are most probably, or most of the countries, they are often buried in the sanitary landfills. So option A is correct. Then option B, screens and grid chamber are examples of unit operations. So let us see that. So in the lecture video, if you have noticed, there are two terms used, uh, unit operations and unit processes. So can anyone say what is the difference between these two?
Operations are for physical separation,
Okay, very good.
and processes is in which some chemical reaction takes place, or
Yes,
it's a biological process.
some biochemical processes, like for example, the secondary sedimentation tank. So, very good.
Ma'am, what is mean by grid chamber, ma'am?
Yes, okay, I'll come to that now. So, grid chamber means, so it is an example for this unit operation in which soon after, like you have a stream of wastewater, here you have the wastewater treatment plant. So in this wastewater you have big floating debris, then you will have this particles which are having specific gravity greater than 2.65, say like for example 2.65, like heavier particles like sand, then grit means those type of particles which are very inert in nature. The term which we should use for grit chamber is inert material, means like inorganic material. So these particles which are very denser and which are very inert in nature, those particles will get easily removed with the help by the process, physical process of settling. So for that we go for a treatment unit called grid chamber.
Okay, ma'am. Thank you, ma'am.
Okay, which is based on like the design and all you would have learned in the NPTEL video. Design is based on the Stokes equation and all. So please go through that design part. So I hope it's clear for you now.
Yes, ma'am.
Okay, thank you. And so let's come back to the unit operations and unit processes. So unit operation means all those treatment stages in which the prime mechanism is the physical separation, like settling. Like there is nothing, like no biochemical processes happening, just the physical processes. So that is what is known as unit operation. For example, grid chamber. Screening and grid chamber are examples. Then you have the biochemical processes in which you have the microbes. You employ these microbes to carry out biochemical processes or biochemical degradation of your pollutant and subsequent removal happening. So those processes are called as unit processes. So the second statement is true. Screens and grid chamber are examples of unit operations, which is true. Third one is comminuting device shreds coarse solid materials and return them into wastewater flow. This is also true because you would have learned about this process, which is this comminutor, in which you would have learned that if still if even after screening process, if some particles are remaining which are large and floating, there is a separate unit called comminutor, that its job is to shred those particles. This comminutor will shred these particles into smaller fraction, and those shredded smaller fraction will uh, will be reaching the wastewater. So that also you would have learned in the video. So option C is also correct. Hence the answer is option D, all the above. So I hope it's clear. If there is any doubt, you can ask. So let us move on to the next question then, if there is no doubt. The fourth question is, which of the following is used for dissolved organics removal? Option A, grid chamber. Option B, equalization tank. Option C, secondary sedimentation tank. Option D, primary sedimentation tank. So all of you please say the answer. I know that you are typing in the chat box, but I'm sorry that I am not able to go back and see.
D. Primary sedimentation tank.
These primary sedimentation tank. Okay. Any other lead? Anyone?
C, ma'am.
C. Okay. And any other answers?
C, ma'am.
C. Okay. So let us see the answer. Okay. The correct answer is option C, which you have said. Option C is the correct answer. So let us see the um, like what each processes are for. So question is that which of the following is used for dissolved organic removal. So let us see the grid chamber. Grid chamber, just now I have explained to you. So I hope it's clear now. So next we have the equalization tank. So can anyone tell me what is equalization tank?
Basically, it is used for collecting wastewater over a period of time so that the day variations can be adjusted in the tank.
Yes, very good. Very good. So equalization tank means like after this screening and all other or say preliminary treatment, the wastewater which is flowing into the treatment, the subsequent stages, like primary sedimentation tank or secondary sedimentation tank, they won't be in uniform flow rate. Sometimes, sometimes today the flow will be not today, sometimes in the forenoon the flow will be q1, after some time the flow will be q2, like that. Like there is lot of variation. Also, like the concentration of pollutant, say if the wastewater is from pharmaceutical company, in which they are using the wastewater treatment plant for treating or removing the pharmaceutical. So when the flow was Q1, when the pollutant concentration, pharmaceutical concentration was C1, when it was Q2, the concentration was C2, and when it is Q3, it is C3. So like there is lot of variation. Usually we design the treatment system for particular flow rate and to treat like to treat wastewater having concentration say C naught. So it's actually rough. We cannot design any system precisely to treat a concentration in this when the influent is having this and that. But say like but if there is huge variation, it will be so much problematic. Like if it is directly coming to the say secondary sedimentation tank, and there are microbes, and sometimes the concentration of pharmaceutical the microbes are getting is C1, sometimes it is C2. So in that way the efficiency of the system will be very low. So in order to address for this variation, there is a separate tank or uh, storage unit called equalization tank, in which water is stored, wastewater which is coming is stored for particular time period in order to equalize the flow rate and equalize the properties like concentration and all, so that after like the effluent coming out of this equalization tank will be having a uniform flow rate and other properties. So then when it reaches the subsequent treatment units, there won't be much challenge for the treatment of this wastewater. So I hope it's clear. Is it clear for you? I hope it's clear. So let us see the next option, secondary sedimentation tank. Secondary sedimentation tank is that first you have this preliminary treatment like screens, then you have this primary sedimentation tank, then you have this secondary sedimentation tank. So in the preliminary treatment, all the floating objects are removed. Then you have the suspended material, like suspended particles, which will eventually get settled in a settling basin. So that will be removed in the primary sedimentation tank. Then in the wastewater you have the dissolved organic matter, which is contributing to your BOD, COD and all. So those are getting removed with the help of microbes in like basically this biological processes, and that treatment is happening in the secondary sedimentation tank. Hence option C is correct, secondary sedimentation tank. And then the option D is primary sedimentation tank. It is primary sedimentation tank is a physical unit operations. So in that only the settling is happening. Biochemical processes are not expected to occur, though we say that about 20% of BOD removal and all will happen, but it is not it is not designed for that. Hence the answer is C. So some of you have said option D, which is partially correct, but the we cannot give credits for that because it is not designed for the removal of organics. It is removed. It is designed just for the settling of settlable suspended particles. Is it clear for you, guys? Please respond.
Ma'am, have one doubt.
Yeah, ma'am. Yeah.
Yes, yes. Please go ahead.
Uh, this secondary sedimentation tank,
Yes.
is it a unit process or uh, what do you call it? The
Okay, actually, the since the biochemical process, secondary sedimentation tank, it is a part of like in the subsequent classes you will learn about activated sludge process. So the secondary sedimentation tank is a part of this activated sludge process. So it is just like that, though the settling of biomass is occurring in the secondary sedimentation tank, which is a physical process, but since the biological system or microbes are involved in it, it is a unit process, not unit operation.
But the aeration takes place in a different zone.
Yes, you are correct. Aeration takes place in the all the biochemical mechanism happens in the aeration tank, but as it is a part of this altogether is like responsible for this say dissolved organic removal with the help of biochemical reactions. We call it as a unit process.
Okay, thank you.
Yeah, thank you. Very good question. Any other doubt, anyone? Let me see if someone is still trying to join, or like I'm not able to see what is happening, like how many people are there. So let us quickly go back and come. Okay. So shall we move on to the next question?
Yes, ma'am.
So the next question is type 1 settling is also known as A. Discrete settling, B. flocculant settling, C. zone settling, D. all the above. Any answer, anyone?
Is it A, ma'am?
A. Yes, that's correct. Option A is the answer. So in the lecture video, you all would have, sorry for my bad drawing skills. Uh, Still, I'll try to draw. So I hope all of you would have learned about different zones of settling in the NBTL videos. So can anyone tell what are the four types of settling which is prominent in the wastewater treatment?
One is screen population.
Can anyone tell me? Okay, let us see. Uh,
Uh,
there are four types of settling. Type 1 or discrete settling, type 2 or flocculant settling, type 3 which is known as zone settling, and type 4 is the compression settling. So these are the four types of settling which are prominent in the wastewater treatment plants or in different processes of wastewater treatment. So let us see what is type 1. So in the type 1 settling, it is a type of settling in which each particle settle individually, like that, like there is no interference of one particle into another, and all your classic classic fluid dynamic equations like Stokes law and all, everything is valid for this type 1 settling. And it is also known as discrete settling. This happens when the concentration of particle is low such a way that the one particle will not interfere the settling characteristics of other particle. And then let us see what is type 2 settling. Type 2 settling is known as flocculant settling because in this concentration of particle is little more high, so that like they aggregate together to form flocks, and then each flock settle as one unit together. So it is known as type 2 settling or flocculant settling. And Prominently, like in primary sedimentation tank, you are expected to see type 1 settling as well as type 2 settling in some cases. Excuse me. And then you will have the third type of settling, which is known as type 3 settling or zone settling. In this, the concentration of particle is higher than this type 1 and type 2, and it is that like one particle uh, one particle will interfere the settling of other particle. They will settle separately, but one particle can interfere the settling characteristics like velocity and all of other particle, and they settle as zone, like one zone will settle like that. So that is known as zone settling or type 3 settling. Then this is more predominant in the secondary sedimentation tank, where you have the flocks of microbes. They are uh, the concentration is high that they settle. You can see the settling as zones, like one zone will settle the other zone, like that. The fourth type of settling is compression settling. In the compression settling, the concentration of particle is very high, so that it is like all the like different layers are like compressed. One layer is compressed over the other. It is like a congested type of situation for these particles. It is found in the lower depths of the secondary sedimentation tank. So these are the four type of settling. So I hope it's clear for you. Any doubt? Any doubt? Shall we move on to next question?
Yes, ma'am.
Okay. So next question is that 100% collection efficiency of particles of specific diameter in a settling tank is obtained when? Option A, particle settling velocity is higher than critical settling velocity. Option B, particle settling velocity is equal to critical settling velocity. Option C, particle settling velocity is lower than critical settling velocity. Option D, both A and B. So anyone know the answer?
Option D, ma'am.
Option D.
Option C.
Option C. Any other lead, anyone? If not, let us see the answer. Option D is correct, both A and B. So this in this question, we are talking about a primary sedimentation tank. So in the lecture videos, I hope all of you would have gone through it. You would have learned the term critical critical settling velocity. So we see critical settling velocity, which is eventually the you would have seen the derivation. You would have seen the derivation that critical velocity will be equal to this surface overflow velocity VO. So you would have learned that in the settling of particles, like a few particles will be here, and if it is hitting the bottom before the detention time t, that particle will be removed. Similarly, if the particle is here, the trajectory is here, uh, like it is not necessary that the particle should be at the top. Even if it's at the bottom or in the middle, if it is getting removed before it flows out, then that particle is removed in the primary sedimentation of the wastewater. So you would have learned about the term critical velocity, which is equal to overflow velocity, and it is said that if like you have an overflow velocity VO, which is defined as the flow rate Q divided by the surface area of flow, which is in this case so no, it is Q by L into B, length into breadth. This flow, this area we take. We have seen the derivation in the lecture video. If not, kindly go through that. So you have this overflow velocity VO, and you have the particle settling velocity Vs. So if the particle settling velocity Vs is greater than or equal to VO, the particle will settle. Otherwise, like if the particle settling velocity is less than VO, particle will not settle. It will escape into the other treatment unit. So that is what you have learned in the week 5. So hence our answer is that A is correct. Particle settling velocity is higher than critical settling velocity, which is VO, and the particle settling velocity is equal to critical settling velocity. Hence option D is correct, both A and B. So that is the answer. Uh, so, uh, so can we move on to the next question?
Yes, ma'am.
Okay. So next question is, which of the following type of settling cannot be analyzed by classic sedimentation laws of Newton and Stokes? Option A, flocculant settling. Option B, hindered settling. Option C, compression settling. Option D, all the above. So, anyone? Any lead? Anyone? Which of the following type of settling cannot be analyzed by classic sedimentation laws of Newton and Stokes? I think I have already discussed about this in this session. So, anyone please say the answer.
The B, ma'am.
Option D. Yes. Any other answer? Alright, let us see. Option D is correct. Uh, Option D, it's discussed in the lecture video that so far our understanding is limited to the discrete settling of particle, which is type 1 settling, and all the classic laws of sedimentation like Newton and Stokes are are applicable to this discrete type 1 settling, whereas flocculant settling, hindered settling and compression settling, these laws are not agreeing, like not applicable. However, recently people are developing various computational fluid dynamic methods in order to predict the settling mechanism of these three. So our question is, which of the following method, in which of the following method our classic sedimentation laws are not applicable? Hence answer is D, all the above. So shall we move on to the next question?
Yes, ma'am.
Okay. So next is a numerical problem regarding the screens. So here it is given that head loss is given, which is 30 mm. Head loss in a bar rack is given, which is 30 mm, and the approach velocity, that is the velocity with which water is reaching the screen, so that is given 0.6 meter per second. You have to find out, determine the velocity through the screen. What is the velocity with which water is flowing through the screen? So different options are given. So this question is based on, like you have an empirical equation which is discussed in the NPTEL lecture notes, regarding the head loss, how to find out the head loss through the screen when the approach velocity and the velocity through the screen is given. So this is based on that. So you may refer to your notes and do this problem. I'll give you about 2 to 3 minutes. So kindly do this problem and then let us discuss the answer. So is it fine? You can refer to your lecture notes now, if you want to see the equation, then you can try out this problem. I'll give you a few minutes time. Now after this we have two more numericals, so with that we will wind up the class. Anyone is trying this problem, or are we just waiting?
You're trying, ma'am. Just give a minute.
Okay, very good.
Um,
If you're not having the equation, I'll write it simply, which is equal to 729 into a square by 5. Where this V should be in meter per second. This V is the approach velocity in meter per second. H would be in meter.
$23 meters per second, ma'am.
23 meter per second. Okay, let us see. Can you hear me?
Yes, ma'am.
Okay. Any other answer, anyone? Anyone else is trying, or should we see the answer? So I guess nobody else is trying. So let us see the answer. Answer is 0.88 meter per second. So have you used this formula? So uh, who has said 23 meter per second? Can you say your name? If you are okay. So let us see the detailed solution. So we have I'll rub this out. अभी क्लास चल रहे हैं। वो क्या है? सुकन्या मैम ऑर्डर किया था। ठीक है ठीक है। सब है ना वो ऑर्डर में? Sorry for the interference. So let us come back. So this is a detailed solution given. You have the empirical equation h is equal to 0.0729 p square minus p square, where v is the velocity through the screen and the small v is the approach velocity. So this equation is given in one of your lecture notes. So I hope you would have seen this in your lecture notes. And what is given is you have the head loss. So the thing with empirical formula is that you have to be very careful with the units. Empirical formula is very simple, means like you won't have to know any derivation and all, but for solving the answers you will have to know what should be the unit of each and every term. So in this it is defined as h should be for h in meter, uh, head loss in meter, and this velocities should be in meter per second. So you have to convert all the velocity. Here the approach velocity is already given in meter per second. And then you have the head loss in mm, that needs to be converted to meter. And then remaining things are pretty straightforward. You have to find out this v, that is velocity through the screen. So after solving you will get it as 0.878 and 0.88 meter per second. Is it clear? Is it clear for you?
Yes, ma'am. Yes, ma'am.
Okay. So basically I guess you would have made it wrong with the units when you
Uh,
got this 20.
Not to the units. I instead of adding, I subtracted.
Okay, okay, fine. So every time when it comes with empirical formula, it is just a matter of like remembering the formula and just applying it with the right units. So this is all about this question. So let us see the next question, which is also a numerical. This is one of the important question which will come in your assignments frequently. Such type of question it is. So let us see. Determine the surface loading rate, uh, surface loading rate and the detention time in minutes of a grid chamber with dimension 12 meter into 1.5 meter into 0.8 meter and flow rate 720 meter cube per hour. So what is given is you have to find out the surface loading rate and detention time. So detention time should be in minutes, surface loading rate should be in meter cube per meter square per hour. So what is given is that the tank dimension is given and the flow rate is given. So all of you please try this out and let us see the answer. I'll give you about 3 minutes time, 3 to 4 minutes. So meanwhile please try this out. ready with the answer? Do you want more time? Or should we start discussing? Do you want more time? Hello? Hello?
And can you start discussing?
Okay, sure. So let us see the answer. The answer is option A, 40 meter cube per meter square per hour and 1.2 minutes. So, what is given here is you have the surface loading rate. Means like you have a tank in which you know like you have to find out the surface loading rate and retention time. Dimensions are given. Flow rate Q is given 720 meter cube per hour. So first of all, surface loading rate means the flow rate Q divided by the this area of flow, that is length into breadth. Again I am drawing it wrongly, should be this area. Means the area with which the um, the flow the flow per unit surface area, that is the definition of SLR. So have to Q by length into breadth, which is 720 meter cube per hour divided by 12 into 1.5 meter, which is should be 720 which is coming as 40 meter cube per meter square into meter square per hour. So this part is clear. Okay. So when you have to find out the surface loading rate, what you have to do is that surface loading rate is flow rate divided by length into breadth. So basically you are asked to find out that what is the flow per unit area, this area, this surface area. So is it clear?
Right. Yes, ma'am.
Okay. Then the next part is we have to find out the detention time. So since it is a continuous flow system, the detention time T is given by volume divided by Q. You would have learned about the continuous flow and the batch flow in the previous lecture, that is week 4 lecture. So in the continuous flow system, the detention time is given by V by Q. So it is volume is 12 into 1.5 into 0.8 divided by, which is coming as meter cube, divided by flow rate 720 meter cube per hour. So when you do this, you will have 12 into 0.8 by 720. It will be 0.02 hours. So when you convert it into minutes, into 3000
Into 60, ma'am.
into 60, sorry, into 60, when you do, you will have 1.2 minutes. 1.2 minutes. So option A is correct. So is it clear? Shall we move on to the next question?
Yes.
So this is the last question. This question is also very important. This often comes for your assignment and other exams. So it says that a settling basin have a flow rate of 2000 meter cube per hour and has an effective settling volume Yes, settling volume that is 15 meter long, 3 meter tall and 5 meter wide. What percent of particle that have a settling velocity will be removed? So this is related to that ratio which you have discussed. That is velocity of particle Vs divided by the critical velocity Vc or overflow velocity. So this is regarding that. So this is the hint. So please try this out and let us see the answer. Anyone with the answer? Should we wait? Anyone is trying? If nobody is trying, let us see the detailed solution. Okay, let us see the solution. The answer is option D, 70%. So I have given you a hint that it is based on the theory which we have discussed before, like in a settling tank. For those the particles will be having different velocities based on the particle size and density, and basically we say that those particles which are having settling velocity greater than or equal to the critical velocity, which is often taken as the overflow velocity, surface overflow velocity, those particles will settle completely. This question is based on that. So this Vs is given, that is particle settling velocity, which is 0.005 meter per second. Now we have to find out the Vc, which is critical velocity, which is overflow velocity, which is given by Q by L into B, which is equal to 2000 by length is given 15 into 5. Width is given as 5, and it will be in, this will be in meter cube per hour, and this will be in meter cube, meter square. So but we need we have this vs in meter per second, so we have to make it into second, this hour into second, by multiplying it with 3600. So it will become 2000 by 15 into 5 into 5 into 3600, which is coming as 7.4 into 10 raised to minus 3 meter per second. Now we have to find the ratio Vs by Vc, which is equal to 0.05 divided by 0.05 divided by that, which is coming as 68%. So 70% is near to this answer, so we have taken. So option B is the correct answer. Any doubt, anyone? Any doubt?
Oh, ma'am.
Okay. So this is all about today's session. So I think we have covered almost all the part which we have seen in week 5. So these numericals, I think they will be helpful for you, and these are important numericals which I have discussed. So today's session we shall close now with this, and thank you for your patience and your time. So let us meet next Tuesday, same time, um, for discussing about week 6 lectures. So before coming to the session, if you watch the videos and then come, it would be helpful for you, because then you can try this out, try the problems in class itself. This will become a hands-on experience for you. So this is all about today. So if you have any concern or anything, you can discuss here. Otherwise, you can leave. Thank you. Thank you for your time.
Thank you, ma'am.
Thank you.
Ma'am.